Hello, my name is Wolfram Jörn. I'm the director of the major in mechanical engineering, and I'll give you a brief overview of our labs. Experimental work is done for the major in mechanical engineering in 5 courses, each of them in a different lab. These courses are material science in the lab for mechanical behavior in materials, manufacturing processes in the lab for manufacturing processes, control of mechanical systems in the robotics lab, energy conversion in the lab for thermal systems and energy conversion, and finally the mechanical design project, which is the capstone, where students use the mechanical workshop. The level of depth of experimental work is different in all of these courses. In material sciences and in the manufacturing processes courses, the hands-on experience is an integral part of the coursework, so students have several sessions during the semester. In the control of mechanical systems course, there's a final project where students use the lab, whereas in the energy conversion course there's only 1 session during the semester where they use the lab. Finally, in the mechanical design project course, which is the capstone of the major, students can use the mechanical workshop during the semester. We're now in the lab for thermal system and energy conversion. Here we've got several devices that allow students to get in touch with equipment commonly used in industry. So we've got refrigeration cycles, power cycles, and industrial boiler. In the context of the major, students from the energy conversion course come here to observe the functioning of 2 power cycles. There's a gas turbine and there's a steam turbine with a boiler. Record the readings of pressure, temperature and other quantities and compare those to theoretical considerations from the course. And by seeing an actual operation of a turbine and by validating their theoretical calculations, they get a deeper insight into the functioning of thermal machines.
We are here at the Laboratory for Metallurgy and Material Science of the Department of Mechanical and Metallurgical Engineering. Within their material science education, the students learn theoretical basic concepts as well as practical skills relevant for material science within mechanical engineering. Generally, the students learn theoretical concepts, analytic methods, as well as the actual practical skills representing relevant or crucial competencies to select, manufacture and for the application of materials and various fields of engineering science. Within the laboratory activity, the students can bring their theoretical knowledge into actual practical application. But before any start of the laboratory activities, we put great emphasis on security measures, and the students receive an introduction on the right safety clothes as well as safety equipment such as the right shoes, the right coats or gloves for the different activities or machines to be used. Also, we teach the students the correct behavior in case of an emergency or in the laboratory at all, as well as in case of an emergency, for example, let it be a fire or an earthquake. Moreover, currently we are working on a digital safety certificate or digitizing the whole content of the security. And the idea is that the students will have to pass an exam or a test and which is required to actually participate in the lab activity. For the laboratory activity itself, it can be divided into 2 aspects, which is the first is the sample preparation, and the second one is the analysis of, for example, the microstructure or phase composition of materials or mechanical properties such as the hardness. For preparing the samples, we have various machines in the laboratory that can be used, for example, to cut cross-sections from the samples, and in a second step to further grind, polish and etch the samples in a multi-step process until the sufficient surface quality is reached. In a subsequent step, the students can analyze their prepared samples using various types of microscopes. For that purpose, for example, we have stereoscope as well as various digital light microscopes to investigate, for example, the microstructure of the materials as well as metallic phases, for example, failure mechanisms or origins of various components or mechanical components that we can provide. A great bonus is the interconnectivity of all digital devices that allows us to share the same images or the observed images on a central screen with explanations from the professor in the lab. Apart from analyzing the microstructure of materials using optical microscopy, the students can employ various equipment to actually measure, for example, the mechanical and elastic properties of materials in uniaxial tensile tests, or to study, for example, the hardness of the materials using a nano-indentation device. In this way, the students can link their observations from the structure of the materials with actual quantitative mechanical properties. To sum up, the laboratory activities within material science allow the students to bring their theoretical concepts and the methods into actual practical application and to learn practical skills of how to use up-to-date equipment in the context of material science.